unit provides to the student what artificial intelligence and machine learning takes to bring into the real world, and discuss when artificial intelligence solution would be appropriate. The differences between AI in research and AI in production are also discussed, including how AI systems differ from traditional software systems. Basic concepts and terminology are also accompanied with examples of successful applications focusing on important aspects of artificial intelligence systems, including the data stack, deployment, monitoring, maintenance, infrastructure, apart from the AI algorithms. In addition, the importance of data is also discussed, including different data formats, the major data models, the type of data storage, the model of databasing, and the processing techniques. When people hear artificial intelligence system, think of just the AI algorithms being used such as different types of neural networks. However, the algorithm is only a small part of an AI system in production. Before discussing how to develop an artificial intelligence system, it is important to ask when or when not to use artificial intelligence to provide a solution. Artificial intelligence has proven to be a powerful tool for a wide range of problems, but artificial intelligence is not a magic tool that can solve all problems. Even for problems that artificial intelligence can solve, artificial intelligence solution may not be the optimal solution. In this sense, it is important to understand what AI can do. AI system has the capacity to learn. In most cases, AI systems learn from sample input and output pairs, how to generate output for arbitrary inputs. Remember, this is a supervised learning. AI solutions are useful when there are patterns to learn. Whether patterns exist may not be obvious, or if patterns exist, your dataset or AI algorithms may not be sufficient to capture them. Understanding the challenges of developing an AI system into production is essential to understand the differences between AI in research and AI in production. In research, the most common objective is to model performance, that is, improving the performance using techniques which often make models too complex to be useful. In industry, there are many stakeholders involved with their different requirements, and often in conflict, which make it difficult to design, develop, and select an AI system that satisfies all the requirements. When evaluating an AI system from a business point of view, it is important to be realistic about the expectation. Although the specified requirements for an AI system may vary on different aspects, most AI systems should have the following characteristics. The system should continue to perform correctly even in hardware or software faults or human errors. With traditional software systems, you often get a warning such as system crash or runtime error. However, AI system can fail silently. There are many ways an AI system can grow: complexity, traffic volume, etc. There should be reasonable ways of dealing with that growth, resource scaling, and models management. It is important to structure the workloads and set up the infrastructure in such a way that different contributors can work using comfortable tools. Models should be sufficiently reproducible, allowing other contributors work on them. The system should have some capacity for both discovering aspects for performance improvement and allowing updates without service interruption. AI systems need to be able to evolve quickly due to data change. Developing an AI system is an iterative process, which never ends when the system is put into production, because it needs to be continually monitored and updated. The first step is to determine the scope of the project, laying out goals, objectives, and constraints in the context of a business. Before developing an AI model, data is needed. Engineering data covers handling data for different sources and formats, sampling and generating levels. Features are extracted from the initial set of training data to develop initial models, which made accessible to users and developed afterwards. When in production, models are monitored and maintained to adapt to changing environments or requirements. Finally, model performance is evaluated and analyzed against business goals and to generate business insight, which may scope out new projects. Note that this workflow is not linear and straightforward. This process looks like a cycle with a lot of back and forth between different steps. Any system can work with data from different sources, having different characteristics and different processing methods. Consequently, storing data is not always straightforward and can be costly. Therefore, it's important to think about which data serialization format to use. Data serialization is the process of converting a data structure into a format that can be stored or transmitted and reconstructed later. There are a few common formats that can be used. For instance, text files are in plain text, which means that they are human-readable. Binary files contain rare bytes, and they are more compact but not human-readable. Data models describe how data is represented, affecting the way your system is built and even the problems that can be solved. Basically, there are two types of models: relational and non-relational models. Data stores or databases are the implementation of how data is stored and retrieved on machines, which is specified by the data format and the data model. In production, an AI system is normally composed of multiple processes that do not share memory, and data is passed from one process to another some way. There are three main models of data flow: data passing through databases, data passing through service, and data passing through real-time transport. As data in real-time transport has different properties from data in databases, they require different processing techniques. Batch processing, where the data is processed in batch jobs that are kicked off periodically to compute static futures, and strip processing, where data is processed as soon as it is generated to compute the dynamic futures.